This is Josh White with JW Math Tutoring. In this video, I'm going to cover the ultimate Desmos guide to digital ACT math example problems, looking at 10 more problems you can solve quickly and easily using Desmos. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
Before I start this ACT math video, I just want to take a couple seconds and let you know about my Improve Your ACT Math Score course, available on both Udemy and Teachable. The course features a wide and comprehensive review of ACT math topics, including how to use both the TI-84 and Desmos graphing calculators. It also includes general strategies, such as back solving and picking numbers, and a review of topics in algebra, geometry, probability and statistics, and other miscellaneous topics as well. It includes over 10 hours of instructional videos and over 20 total hours of videos, including solutions to various problems. So please check out that video if you're looking for more help on improving your ACT math score. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And let's go ahead and get started with this video. Welcome back to my Ultimate Desmos Guide to Digital ACT Math. In this video, which is part 6, I'm going to go through 10 example problems where you can use Desmos to quickly and easily solve them. However, this is a bit different than previous videos in that there are not specific operations or functions you have to type in, like was covered in the core skills, intermediate skills, and advanced skills. Instead, this is just kind of a general Desmos use to show you how you can easily and quickly solve some of these ACT math problems. Also, just so you know, there will be a link in the description and in the pinned comment of the PDF file that has all of these problems in it. All right, so let's go ahead and get started here. So question number 1, actually just zoom in so I can make it a little bit larger on the screen here. You have two functions that are intersecting. Okay, they intersect at 2 points. And it wants to know which of these answer choices has the same solution as the x-coordinate of the intersection of point A. Point A would be the top intersection point right here. So all we have to do is just graph out the functions, get the value of point A, just delete everything else. So that's the value we're looking for. And now I can just go through the answer choices and see which of them. And there's multiple ways you could do this. I'm going to use regression, but you could also graph these out and you could see if they intersect at the same point if you wanted to. So notice, here is the first answer choice. Is the solution to this 2.0571? No. Okay, next answer choice. Notice it's identical except I get rid of the minus here. Okay, that one is not correct. The answer choice does not match up. I'm going to skip H for now just because I already have the right side, already have the square root there. So now I'm going to go to J. Notice this one is not correct. Now for K, I can just delete this, and notice I get the same correct answer. I get the same solution for the equation in K as I do for the x-coordinate where they intersect, right here at this point. Now there's probably other ways you could do this too. Like I said, you could graph them all out, but I think for me, this is the quickest and easiest method to do this because I'm just changing between the answer choices. I'm just changing, like I'm getting rid of a minus sign from F to G and from J to K, and deleting the square root and then just retyping the 3x minus 3, between F and G and J and K. All right, let's look now at the next question. So here you have a graph of a circle. Looks like a unit circle, but it's technically not because the radius isn't 1. They tell you the radius is 2. Okay, and we want to know for this 150-degree angle, which goes out and ends at point A, what are the coordinates of A? All right, so first of all, if you use process of elimination, you can get rid of G and H and J, because notice here point A has to have a negative X coordinate and a positive Y coordinate. Okay, so first of all, right off the bat, these are already gone. All right, so now what I'm going to do is, first, and this is a pro tip. This is not covered in the advanced in my guide or anything, but just to easily quickly graph a circle, just type r equals whatever the radius of the circle is, and that will give you a circle centered at the origin with the radius that you want. So here is the exact circle shown in the picture. Just type r equals 2. Now, all we have to do is just graph the 2 points and see, like this, comma, 1/2. Okay, so letter F, I'm going to do that one first. Is this point, out here on the circle corresponding to 150 degrees? The answer is no, it is not. Therefore, it has to be K just by process of elimination. But let's just double check. So if I get rid of this for K, and then if I get rid of this, notice here is the point, and yes, it looks like if I extended a line here from the center out to this, that looks like roughly a 150-degree angle. So K is the correct answer for this one. And that's it. And that's all you have to do in Desmos. All right, scrolling down to the bottom, question number 3 here. You have an equation that has some trig functions in it. So there are multiple ways that you could do this one. One way is you can literally just type the equation in by taking the first factor, setting it equal to 0. Notice you do need to be in degree mode. If you're not in degree mode, then it's, if you're in radian mode, it's going to give you some random answer like that. But you need to be in degree mode, which we are. So notice right there, we get an answer of 120. So right off the bat, I know this is out, this is out, this is out. So it's either 0 or 60, when we're looking at the second equation. So I'll use x2 here. What do I get for that? I get 0. So the correct answer for this one is just letter A. Again, nice, quick, easy, simple way that you could solve this in Desmos. Now, just to show you an alternate approach you could do for this one is you could just do graphing. So, for example, you could graph out the function like this, right? And now, since it's equal to 0, that means we are looking for x-intercepts. And let me just see if I can do this. Center. Okay, there we go. So I put a restriction on here because it wants x to be between 0 and 180 degrees. So I put a restriction on the domain. So now my graph, you have to zoom out here, it's only between 0 and 180, right? So where is it equal 0? Well, okay, obviously 1 is right here. It's a little difficult to see because, the amplitude of this graph is the distance above the x-axis is not very large. So I zoom out here to see it. I can still see the clickable points. You know what I'm saying? So like, for example, here's one. So we know 0 is one of the answers. So it's either A or B. And then the other one right here, it's at 120, and that's it. Okay, this is just a min point. That's not an x-intercept. But here are my two values. This is how you could easily solve this problem just by graphing it and getting the correct answer. All right, next question. Here you have one where you have 4 different functions. You have an exponential function, you have a linear function, you have a quadratic function. So it'll give me a second to type all this stuff in. And then you have a cubic polynomial function. Cx plus t. Okay. So first, let's add some sliders. It tells us that a, b, c, and d are all real numbers greater than or equal to 2. So whatever. Let's say like this to 2, this to 3, whatever, this to 4, this to 5. Okay. So which of these exceeds the values as x goes to infinity? So in other words, what it's asking is which of these takes off and is the steepest as x moves to the right. Okay. All right, well, it's obviously not the linear function, so we can get rid of that. Notice that everything else is like way up here, already up in the 200s, whereas this is down at like, in the 20s. So we can get rid of that. Now let's zoom in and see what's happening with the various other types of functions. Okay, it's not going to be the blue one because the blue one is technically below the green one. See, like right here at 6.5, it's at 109, whereas this is already up at like, 100 and whatever. Even up here at like 4.3 something, it's already up at 250. So get rid of this blue one. Let me just see. No, there's a trying to find a way to change the color of this. Let me copy this. No, that's not what I want. Undo that. I wanted to. Nope, it's giving me the same color. There we go, finally. Supposed to be able to long click on it and bring up the menu to change the color, but for some reason it's not doing that. All right, so now the question is, what's going on with these? Which one is the, the higher one? So it looks like the purple one is the one that's to the left, which means it's the one that is above the green one to the right. So it looks like the purple one, which is the cubic one, is going to be the higher one. However, if you fool with the values, what you'll see is, notice as I move, as I say increase the value of b here, the green one overtakes the purple one. Again, if I slide this back over here, notice the purple is to the left of the green, meaning the purple has the higher value. It goes to infinity quicker. However, if I increase this, notice the again, the green, the exponential one, moves to the left of the purple, of the cubic function. Therefore, the correct answer for this one is going to be letter A. It is the exponential function that will exceed the values of all the other listed functions as x approaches infinity. Next up, question number 5. Here you have a system of equations with 3 variables, x, y, and z. Now, as it's written, you cannot graph this because we only have an xy coordinate plane here. However, what you can do for a problem like this is you can type in each equation, then you type in the answer choices. So for example, say z equals -3. And the value of z, which is a solution, will make all 3 of these intersect at the same point. So for example, we check answer choice A. Do they all intersect at one point? No, therefore it's wrong. Let's do the next one, 1.5. Technically you could do 1 and 1/2 like this, or you could type 1.5. Okay, again, they don't intersect at one point, so that's wrong. Let's check 4. Do they all intersect at a single point, a single solution? No. Let's check 5. Yes, they do all intersect at one single point right here. Therefore, that is going to be the correct answer, letter D. All right, next, let's take a look at number 6. So, here you have one where you've got some expressions, or some equations actually, with multiple values. Okay, and now let's say I just wanted to try add some values for a and b. Now the problem is, if you notice, a and b have to have a difference of 5, so you can't just pick any random numbers for them. So let's set a is 12 and b is 7. Okay, so that returns c is 26. So it appears that would be the correct answer, but in order to do that, in order to know that, I would have to pick at least 1 or 2 more other values just to confirm. So let's say now I move it to 13 and 8. Okay, it's again 26. So most likely the correct answer is going to be letter B. Right here, 26. However, here's a little trick that you can do which can actually confirm that it is 26. I am going to rearrange the first equation to make it A equals everything else on the other side. Now, what you do is we get rid of this, and we're only inputting the value of B. That will determine the value of A, and then A and B both get fed into the second equation, which determines the value of C. And notice here, if I move my value of B around, whether it's negative, whether it's positive, the value of C does not change. It stays constant at 26. So that confirms that the correct answer to this problem is letter B, 26. Okay, next up, here you have a problem asking about taking a graph of a parabola, quadratic function, and reflecting across the x-axis and asking which of those results is, what happens when you do that. So, all we're going to do here is just graph the original function. Let's just let a equal whatever, 2, and we'll let b equal 3. Okay, so there's our original function graph. All that matters is the absolute value of a and b are not equal. So just that's fine. Absolute value of 2 is 2, absolute value of 3 is 3. They don't equal. All right, now we just go through the answer choices and we see which one of these shows a reflection across the x-axis. Okay, so it looks like it's letter A, but let's just check out the others just to confirm. So if I do this, all right, that's just the original graph we were given, so it's obviously not B. So let me just go through here. Okay, so this is obviously wrong. Now, if I make it plus, okay, that's a shift to the left. That is not a reflection across the x-axis, so let's get rid of that. And now with these other ones, if you notice, they've switched the x's and the y's. So these are actually going to be horizontal, parabolas like this. Like, no, that's not a reflection across the x-axis. That's a completely different type of function. And then if you do this and make this plus, yeah, again, not even close. So this just confirms the correct answer is letter A. And again, you can very quickly, easily do this on Desmos just by, graphing and basically the technique of picking numbers. All right, next up, number 8. Here we have a function, and it's asking what the asymptotes of this function are. So all we have to do is just graph this function, and then we can go through the answer choices, graph the asymptotes, or graph the lines, and see, do they look like asymptotes? So when we look here, the answer appears to be yes. It's a vertical line. It's going to infinity from the left of -3. It's going to negative infinity from the right. So yes, -3 clearly appears to be an asymptote. So that means, okay, could be A, can't be B, okay, could be C, could be D. Now we need to go through and narrow it down further. So let's check x equals 3. All right, does that look like an asymptote? Yep, sure does. Again, goes to infinity on one side, goes to negative infinity on the other. It's not just like, random, it's not just like a vertical line going through a random point on the graph. All right, so that eliminates A, because that does not have -3. So now the question is the asymptote at y equals 0 or y equals 3? So we can graph both of them, and I'll just get rid of these just to make the graph a little bit less cluttered. Okay. So which one is an asymptote? Well, hopefully you recognize it's clearly y equals 3, that, as we send x to infinity, both on the positive side and the negative side, they're approaching this y equals 3 horizontal line here. Whereas at 0, there's nothing approaching. I mean, it goes through the single point here, but there's nothing that's going towards it or getting very, very close to it on either side of the graph. Okay, so the correct answer for this one is just going to be letter D. All right, next up, question number 9. Here you have a problem where you're given an expression. Start doing the division sign first for the fraction. 10 over 2. Okay. and they're told that n is a rational number. So which of the following statements about this must be true? So all we have to do here is like pick some values for n and use process of elimination. So let's just let n equal 2, okay? That's a rational number. It's, anything can be written as a fraction, 2 over 1. All right, so notice here I get a negative number. So which of the following must be true? Okay, must it be true that this expression is positive? No, I found at least one example where it's negative. Okay, now what about, is this a rational or irrational number? If this was a rational number, then we could rewrite this number as a fraction, and we would see the fraction sign in here. But it is not. It is an irrational number. So therefore, we would get rid of this, as a possible answer choice. So now the question is, must it always be a negative number, or must it always be irrational? So let's see what happens when I move the slider. So notice as I move to the right, it gets larger in the negative direction. But what happens if I move to the left and make it negative, which is fine? Okay, it's getting smaller. But what about if I jump it up here to like negative 30? Notice here, eventually I can cross and I'm getting positive numbers. So is it, must it be true that this expression is a negative value? No, it is not. I just found at least one example where it's a positive thing. So by process of elimination, the correct answer here is letter C. Also, it's going to be letter C because of this square root 14, which is an irrational number. But if you didn't know that, this is how you could just quickly and easily use, a slider along with process of elimination to eliminate or narrow out the three incorrect answers. All right, let's look at the last problem now. Number 10, for which value of this function is it undefined? Okay, so can quickly and easily do this one just by graphing the function. And now I'm going to graph x equals those various values, okay? So we got -2, -1, 1, x equals 2, so on. For the function to be undefined at one of these values, that means like at where these vertical lines, quote unquote, intersect the graph, there will actually not be an intersection point. Basically, there would have to be either be a hole in the graph or the graph would not exist, in some other way at that point. So notice, x equals 2, it is defined because there's a y value right here on the graph. Remember, the graph is the red, the red line here. It's technically the line y equals -1, but just ignore that for right now. So the point is, here at x equals 2, the function exists. There's a y value. Okay, so get rid of that one. All right, what about the other? Which one of the ones are clickable? So notice here, x equals 1. It's clickable. There's a y value. It's -1. Okay, so it's not undefined. It is defined. Here, at x equals -1, again, there's a y value, there's a y coordinate, it's -1, the function is defined. Now, what about at x equals -2? So if you notice what happens here, it's not clickable. There's no clickable point like the other three, and that the reason is because technically the function is undefined and does not exist. And if you take your mouse and hover over it, once you get over, it's kind of tricky to land right there. -2, see where it says -2, comma, undefined. So that's the correct answer. This is how you could solve a problem like this in Desmos, basically by using graphing. And so, as I said, the correct answer for this one is just going to be letter A. I hope you enjoyed this ACT math related video. If you did, please give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you're looking for more practice in improving your ACT math score, please check out my course, Improve Your ACT Math Score, on both Teachable and Udemy. There are direct links to the course on both sites listed in the description and pinned comment of the video. Otherwise, good luck as you're preparing for the ACT math test.